Yo, hi. So my name is Benoît Quenaudon. I work on the Cash App at Square, and so I joined Cash App a year ago. And when I joined, I was really surprised on how the clients were interacting with the server. And so I thought it was an interesting enough topic to talk about. So we're going to see that's the app today. And so Cash App is basically, the main feature is P2P payment. You can send or request money to anyone. And so we're going to see, I'm going to send money 3 times with a different result every time. And then we'll see why, and we'll go through the history of the implementation. So first, I send $3 to Matt. The request goes to the server, and server tells me, you don't have any debit card to be debited, so link a card. I do so, and now I've sent money to Matt. This time, I'd send 800 to Matt again, and the server tells me that it wants to verify my identity. We call that IDV for ID verification. So I set my name. Then it asks me for my birth date, my address, and the last 4 digits of my social security number, the SSN. And finally, the server says, OK, you just sent money to Matt. Last example, $5 to Matt. And this time, the server tells me, you already sent $5 to Matt. Are you sure you want to do that again? Isn't it a mistake? And that's done. Also different this time, we have a small promo message at the bottom to invite friends. And yep. And so what was interesting here is that so this screen and the one when I select Matt as a recipient, the client didn't know beforehand what would the server send back. The client had no idea which view would be displayed, what would be its content, what would be the endpoint I would have to hit later on. Everything is just server-driven, and that's really interesting. And so we'll see how incrementally it's been developed over the years. So we go back maybe 7 years to Cash 1.0. And so, by the way, the server-driven thing is also happening on iOS and web. So every time a client sends something, the server says, OK, now you need to display this with this data. So back then, there was only the feature to send money. That was it. So we would send cash, send an amount, and then it would tell you, OK, we're going to pre-fill an email for you. And then when you receive an email, you'll get a link that will allow you to link your card and do other things. And yeah, it would look like this. And so it says it will link a card, but actually there could be different scenarios. So if I already linked a card, it could ask me just to confirm that I want to do the payment. It could do IDV again, the ID verification. And that was it. So basically, it would be in the payment flow at which step of it are we was the thinking. And so the server would give back steps. So there would be only 3. Do I need to link a card? Do I need to do IDV? Or just confirm? And we would also merge some. So for instance, if the server would send link card and confirmation, we would say, link your card to confirm that you want to pay this person. And that was Cash 1.0. And so it's basically just an enum. There is no payload. And the client will have a map between those values to some layout already hard-coded on the client. And so now 5 years ago, we noticed there were some limitations. So there was this screen to ask for the last 4 digits of the social security number. sometimes this would fail. So for instance, if someone had middle names or maybe missed an accent or wrong birth date, this would fail. But what we wanted to do is, in this case, we want to ask for the full number. And using denum, there is no way to tell the client, I want you to do IDV, but instead of asking for the last 4 digits, ask for everything. And so we decided to break this enum into data objects, which would include those semantic data. We call that blockers, and like the philosophy would be, the client says, I'd like to send a payment. And the server would respond, if you want to do that, you need first to satisfy all those blockers. So there could be 1, there could be more, as many as the server requires. So for instance, that's the IDV blocker. And instead of just a blank enum value, we have everything optional. Do we need a birth date? Do we want the full SSN or only the last 4, full name and address? And we would do the same for other blockers. But so the app kept growing, and so, for instance, linking a card could happen on many, many situations. When I send a payment, when I want to receive a payment, because payments were, at the time, from debit card to debit card. Maybe when we sign up, we want to ask the customer to link a card. Maybe in the profile, they just want to link what to their account. Same for confirmation. If it's a duplicate payment, are you sure? If it's if you're sending money to someone who is not in your contact list, are you sure? These kind of things. And there was just too many situations for the client to know every time in which context the blocker needed to be displayed. That meant that the client just didn't know what the proper text would be. And that's when we decided blockers now had only semantic data. Now let's make presentation data as well. And this was the epiphany. And so, for instance, I'm going to give a simple example. The client would send an execute contract request, which could be, I don't know, send payment, whatever. The server would give back the response. And on the client, we would have like a really big list of if statements, if this is this response, inflate this layout, and just inject the data from the response. So here it's a status result. And so this view is a status result. And we'll see how the blockers map to the view. So first, we have an icon. The blockers just send an enum of the icon, and the client would be a map. If this is this value, show this icon, these kind of things. We could also display none. The main text would be just text. Then we have 2 primary buttons, which are heavily configurable. So for instance, the button action would be would let know the client where to take the customer once this button is pressed. So the home screen or link card, or it could also open a URL. And everything would just be sent via the blocker. And as well, the promo message we saw is blocker driven. That meant when we didn't see any, the server just didn't send any. And that's it. So everything on the screen is filled by the server. The client doesn't have any hard-coded strings or like information. And that meant that one blocker view could be used in many situations. The client didn't need to know the context. We could reuse views all over the place. And it was just generic data rendering. But then what we would do, we have a new blocker. Let's say we have existing blockers, but none of them match the new design, because designers always come up with new ideas. So let's make a new blocker. So new blocker means new implementation on the clients, all of them on the server, new API endpoint, and you just keep on growing and growing. And so this is all the blockers layout we have in the Android app. So it's, I don't know, about 100 maybe. So that's a problem we want to tackle. But that's the state of the app right now. And so Cache 3.0 came out last Christmas. And so the new limitations we had and that we wanted to fix were first, skippability. So for instance, when you sign up, we ask you if you want to link a card beforehand, but you can just skip that. The fact that you can skip it is hard-coded on the client, which means that if you wanted to change that, or if you wanted to add a new blocker or change something, it would involve a client release, which, as we all know, is painful. The blockers ordering, so the server could send batches of blockers, like we saw for IDV, or when you sign up, we could ask for your name, if you want to link a card, if you want to invite friends. And the order in which we want to render that is also hard-coded on the client, which sucks. So we put those two information into something we called blockers descriptor, which would be just telling the client, the next blocker is this view, and this is skippable or not. And the other one would be scalability. As we saw, there is too many blockers right now. And on every new blocker, the complexity just goes to the roof. So we decided to make something generic that could suit most cases, that we would call a form blocker. And so we defined a list of possible elements, which could go from just buttons or even space. So the server would be able to really drive the way the layout happens. Money element for when we show amount, these kind of things. And it would be a basic vertical linear layout. So just every element from top to bottom. And the blocker would be just a list of elements and two blocker actions. And so for instance, those three screens are from the same blocker, the form blocker. And we just, the server just sent many different elements. And so briefly, how do we share the data format on platforms? We use protobuf, which is developed by Google. It's a protocol to serialize data. And it was the code we've seen so far, which is something like this. You can define class types in them. You can create your own types, these kind of things. And so Google would provide code generation for this. And so each platform would use its own implementation and everything. Protobuf supports, I think, 5 languages, including one in Java, but the generated code is quite ugly. There is like a ton of methods, so not really good for Android. So Square developed something called Wire, which does exactly that, just code generation from Podos to Java and Kotlin right now. So server uses it. Server uses Java. Android uses Kotlin and Java. I forgot what the web does actually, but I asked the iOS team and they just have some really complex script, so they're in trouble, but maybe someday Wire will generate Swift code, I don't know. And so there is many challenges into this kind of system. One would be backporting. So we have a new blocker. This means all clients had to implement it. We did a release. Now we can just start using it. But it's not actually true, and we'll see why. So this is our basically the percentage of users per app versions. for this year. And so we have a 2 weeks release train. So you can see that on the graph. Every 2 weeks there is a new version. But like, let's say even like this month, there is still like 0.7% of user on 239, which was released last year. This means those person cannot see the blocker. And it might sound like really a few. Like when you upgrade the mini SDK, if there is like 0.7%, you don't care about them. But we have like 7 million customers in the US, so that would be roughly 50,000. So it's not really negligible. And so we have a few strategies we can apply. So first would be the force update. If it's I don't know, security critical thing, the server has the ability to just send a notification to the app that would force the user to update. And if the user don't update, the app closes and the user cannot use it anymore. Otherwise, because web apps are always up to date, we would just be able to, as shown earlier, maybe click on a button, goes to the web app, and complete the blocker. Otherwise, we could use a different old blocker with a different layout, but fill it with the new presentation data. So maybe, I don't know, maybe the image would be different, maybe there would be no image, maybe the text would be different design or whatever. But this is something we can do and the server would know it's an old blocker, but in this case it means that it's for this other blocker kind of thing. And otherwise we could use just a different blocker, but as is. So for instance, when IDV was released, there was no way to use IDV people before that. And we also had a Facebook account link functionality. And so it was like, if you're above this version, we sent you the IDV blocker, and otherwise the Facebook account thing to verify your identity. The last option would just be don't send it. Yeah, I don't know. Maybe when you sign up, we don't have to ask you to link your card if you don't support it. And so it was a tricky one though, because at first we started to snip some blockers in old version, but send them on newest. And that meant that some users that did the same thing would have different data, like the state of their account would be different. And the consistency would be just the root of many bugs and many headaches. So we decided if we need to skip a blocker, we just skip it everywhere. If we need a blocker, we just find a way to satisfy it. So there was bug porting. Bug hunting is also funny. So let's say there is a bug on the client. Because most of the logic and its more complex part are on the server, it's actually really hard to know if it's a client bug or a server bug. And yeah, at the beginning I was really confused, and so the approach would be just to narrow down the scope of the bug as much as you can. So for instance, we would check what the logs of the server to check the request or response. Is everything okay? If it is, might be the client. Otherwise, if Android and both iOS get the bug, it's likely to be the server. But sometimes, yeah, it would be really hard. Also the complexity, even though it's not a client challenge, because we get the easy part, server team is really, really busy and much bigger than the clients. Like a functional team, we would have 1 Android, 1 iOS, and maybe like 5 server people. And the 5 server people would be much more busy than any of us. And even in their code, because of the client supporting blockers or not, they would have like, if the Android is below that, do that, else another logic. The same for iOS. Android and iOS are not in sync sometimes. And I guess there is like some if statements all over the place. Not a place you want to live in. But anyway, that's the server problem. Integration. So the thing with a protobuf, what we saw earlier, is that it defines a set of fields and classes that everybody use on the platform. But for backportability as well, every field are optional, which would be like in Kotlin, everything is nullable. And the thing is, when you, on your platform, start using it, you need to ask yourself, can I expect it to be set every time or not? Like basically in Kotlin, when you do a bang bang, every platform kind of has to do that. And we could get crash sometimes because of that. As well, if the server sends by mistake blocker the client doesn't support, protobuf make it so that the field is just ignored, so the client doesn't really know, and all is good. But so, for instance, once the client added a new enum, like a new value to an existing enum class, and that was the problem because the field was known by the client, but because the value was nowhere to be found, everything crashed, and it was really sad. Yeah. But so there is a good side to the complexity. First, and the real heavy logic only lives in one platform. We don't have 3 or 4 teams rewriting the same really complicated logic around payment flow and customer account management in every platform. Just the server does that, and that's it. And even though I'm not on the server, it's a real win for everyone. And yes. As well, let's say the PM would come up with some idea, or we would find some bug, and most of the time we would just realize that there is no client change involved. So the server would just change the code, and that's it. Customer would get the latest thing. And so in correlation, the client logic is quite simple. The only thing really tricky is just to make everything generic without making it hard to debug or these kind of things. We just basically get something from the server, render it without even thinking what does this data do, send the result to the server. And so same as above, but like we can update and fix bugs without client releases. So we don't have, as we saw earlier, we don't have to expect the user to update or to force them to update. We just change some server code, and they get the latest thing. And yeah, we do that all over the place. We have also feature flags everywhere. So we can, like we would create a feature flag and create the blockers early on. Maybe the implementation would take months, I don't know, can happen, but at the time, everything will be ready, and the server would just need to switch things on and off. And so something else we've been thinking recently would be a server-driven design system. It's like the designers want to be fancy, and they want to control like how things render style-wise remotely via the server. And so the blockers went from semantic data to presentation data, and now they want, I don't know, design data? Maybe it's presentation data, but I don't know. Apparently the iOS team already does that into their view model. They have like just the data and then how to design those. But in Android we don't have that, and it's a bit scary, but that might be a big challenge for the future. And that's what I have for you today. Thank you. I will. So I don't know if there is any question. I'll be happy to take them here. I don't want to retain everyone, so yeah, it's okay. Anyway, yeah. Just come see me if you have any questions. Thank you.